The turn of the year is always a good moment for a review of what has been achieved in the ending year and an outlook on what is in the pipeline for the foreseeable future. Welcome to the IoTT channel in 2023. I'm Hans Tanner and I'm happy to see you. Welcome to all new subscribers and welcome back to everybody else. First of all, a happy new year to all of you. I wish you a joyful and prosperous year and plenty of time to play with the trains. Looking back on 2022, there were three major projects that kept me busy. First, the PurpleHat sensor, which is my first train-side sensor and provides precise measurement of the travel distance and the speed of a train. Second, components that extend the functionality of or add new use cases to the Arduino-based DCC EX command station. And third, a restructuring of the IoTT software along with some new functions added to the IoTT stick. By the way, I just released version 1.5.19 this week, so you may want to update your IoTT stick. Now let's review the current status of these projects in more details and then have a look at what might be planned for this year. PurpleHat was the project of the first part of the year. Well, it really was the continuation of the layout GPS project I started in 2021. Unfortunately, the Bosch B&O 055 IMU sensor, which is used for the orientation function, turned out to be hard to get. In fact, I tried with several suppliers, but no luck to get it for a reasonable price. So I decided to release a version of the sensor that only can do precise distance measurement and provide a tool to automate the speed matching or better speed profiling process shown in video number 94, which has created a lot of interest from many users. However, if you look at the PurpleHat sensor board, there is a mounting spot for adding a B&O 055 sensor board, should it become available again. And the software to support it is already in the IoTT stick. On the other hand, I am also watching what's going on in the IMU sensor development, and there are several interesting new products in the pipeline. So, time will tell in what direction this project is going. The goal remains the same, which is creating a sensor system that makes it easy to set up and operate signal-based train control without the need for tons of block detectors or position sensors. The second project that gave me some headache last year was the RedHat, or as I like to see it now, everything that has to do with add-ons to the DCC EX Arduino-based command station, so the RedHat shield, the power shield and the modular enclosure system. If you have been a viewer of the IoTT channel for a while, you remember when all of this started out. In video number 79 I combined an Arduino with the DCC EX software with an IBT2 H-bridge driver, a Loconet interface board and an IoTT stick, and made them work as Loconet command station. That worked without problems, and in fact I know that there are viewers out there who are still using that setup. So based on that I decided to design a board that would integrate all elements in just one device, and a little later I had the RedHat board working. Only to conclude that this was the wrong approach. Why would I want to force people to acquire a completely new device when 90% of everything they need is already installed on their layout? Would it not be the smarter approach to build on what they already have and make it better? With these thoughts I dumped the RedHat in video number 95 and started over again. Well, not exactly, I just rearranged the building blocks to an Arduino shield and called it RedHat Shield, which I introduced in videos number 97 and 99. In a nutshell, it provides Loconet capability and Wi-Fi connectivity to the DCC EX Arduino stack, so that the user can benefit from a smart do-it-yourself command station while still using a wide range of commercial throttles and sensor devices. As part of these activities, I started to participate in some Arduino and DCC-X related groups on the internet and signed up for the DCC-X Discord channel as well. This was very interesting and useful as it gave me some insights into the user base of do-it-yourself command stations. I mean, the question is, why do people spend $400 for a commercial command station if they could have similar functionality for about 1/4 of the cost? After a while, my conclusion was, and still is, that a do-it-yourself product like DCC-X and Arduino is attractive to people on tinkerer and engineer level, to use the DCC-X terms, but not very much so to the conductor level folks. So people saying, I want electronics, I want it to work flawlessly, but I don't want to know how it works. Now, to change that and make a do-it-yourself command station more attractive to those folks, I identified 4 areas that need improvements. That kind of became the guidelines for my further development activities. First, simplicity. Ideally, everything is plug and play and expert level knowledge to build the command station is not required. That was one of the reasons for using the Shield form factor, so individual modules can be connected together, no soldering required. Second, connectivity. It is nice to be able to control some local block detectors or turnout servos directly from the Arduino board. And it certainly is attractive to write some local automation scripts that are directly compiled into the command station code for engineers and some ambitious tinkerers. But for all others, and also for larger layouts, the concept hits some hurdles. If the layout has a certain size, we need distributed devices like feedback modules or servo decoders that are interconnected using a layout control bus and not individual wires going back to the command station. For that reason, I added a lot of connectivity options. Loconet to connect throttles, turnout decoders and feedback modules, MQTT for long-range communication via internet, a Y-throttle server for smartphone apps like Engine Driver, and a Loconet or TCP server to wirelessly connect computer software like JMRI. Third, performance. The standard Arduino motor shield with 2 amps or so output current turns out to be a little weak to power a layout and sometimes even a single decoder at low speed, which means relatively strong current pulses from the decoder's PWM driver can trip the overload protection. Tinkerers, of course, have found workarounds using external drivers like the IBT2 module, but again at the expense of added complexity, jumper wires and soldering. That's the reason why I put together the Power Shield introduced in video number 109, which brings 5 amps track current directly to the Arduino stack and also supports service mode programming. And fourth, aesthetics. Tinkerers and engineer level people like to see PCBs stacked together and jumper wires all over because they exactly know what every wire is doing and in most cases are eager to explain to everybody how it works and why it is needed. Not so the average user. He wants to have everything in a closed box that looks nice, ideally is connected with only a few wires and makes him look to his friends like a competent model railroader and not like a techno geek. That's the reason why in the last few months I designed the modular enclosure system for the Arduino stack, introduced in video number 108, with enclosure frames for the most common modules. So that was my journey of learning and supporting do-it-yourself model railroading this past year, and going forward I plan to continue to work on making model railroad control systems more plug and play and user-friendly for people who are not necessarily technology experts. Finally, the software side. There were several updates to the IoTT stick software with bug fixes and 2 major changes. The first change was restructuring the connectivity options by splitting them into a command source and a communication server group. Before that, it was one single option list that started to grow out of control, as it had to have a single line for each possible combinatorial setup. Now it is pretty clear the IoTT stick needs to get the commands from somewhere, that's the command source, and there is the possibility of providing servers for different communication protocols where other devices can hook up to. The command source is limited to selecting one single source, while on the server side, several servers can be active and a multitude of clients can be connected into each server at the same time. This concept gives a lot of flexibility, as shown here, where you see a list of all configuration options. The second major change was the addition of a Y-throttle server. When activated, the IoTT stick provides and broadcasts a connection port for smartphone apps like Y-throttle or engine driver to connect to. To make it work, all you need to do is connecting the command source of the IoTT stick to an active Loconet and activate the Y-throttle server checkbox. As Loconet source, you can use a wired Loconet via Loconet interface, or a Wi-Fi based Loconet access, either a Loconet over TCP server or an MQTT provider. With the latest software update, I also added a connected server list to the Y-throttle server page, where you always can see what throttles are connected and what local addresses they are running on each throttle. For 2023, I have several projects in the pipeline. There will be further improvements to the DCC EX related products, the first coming later this month, with the for now final revision of the PowerShield board. And as spin-off of that project, I am thinking about doing a version that can act as booster with user configurable track current and correct current measuring and reporting. In a similar lab review a year ago, I also announced a new project dealing with wireless charging. Unfortunately, as the other projects had priority, there was no progress in that area. But it is a topic I am still interested in, as it would allow to recharge train-side servers on the fly, without the need for power pickups on the wheels, which add a considerable amount of roll resistance. Then, of course, I would like to work more on sensors of all kind, and in particular, sensors that do not need a lot of track gaps and wiring, so that ideally it becomes possible to automate or have signal-supported operations on a temporary layout setup. That's my vision, at least. So there is plenty to do, and I am not running short of topics I am interested in. But for this video, that's it. I hope this information was useful or at least interesting for you, and you have some ideas what's in the makings for this year. If you would like to propose additional topics, please let me know in the comments. And if you like my work, please click the like button below. Doing so keeps me motivated, and you help to promote this video and the IoTT channel in general, because YouTube likes the likes. Thanks for watching, and see you in the next video.